Hello everyone. In this video I'll be talking to you about inheritance. So let's get started. So when it comes to object-oriented programming, there are two common ways to relate to classes in a meaningful way. And those two ways are inheritance, which is what we're talking about today, which is basically an is-a relationship. And there's also another way to relate to classes in object-oriented programming, and that is composition, which is a has-a relationship. Okay? So we're going to start with inheritance today. So what is inheritance? Basically, with object-oriented programming, the advantage of object-oriented programming is being able to reuse code. So if someone else has already written a class and it already has the definitions, everything's written, and we happen to have a project that we have to do that can make use of that class that someone else wrote, but with maybe a little bit of change here and there, we can use inheritance if, of course, the class falls under the is-a relationship rule. For example, every employee is a person. So let's assume someone already had written a person class that has everything that we need, but we're writing a project about an employee. So we're writing an employee class. Well, the beauty of object-oriented programming is code reuse. So if someone already wrote a class called person, we can easily just inherit from the person class into our employee class, and therefore kind of reuse all of the functions and variables that are in the person class. So if the two classes has a is-a relationship, then we can use inheritance to reuse that code. So if someone already has a person class and you're writing an employee class, because every employee is a person, we can very much use the inheritance relationship here. So inheritance lets us create new classes from existing classes. That's kind of the beauty of object-oriented programming, is being able to reuse code. The new class that we take or create from the old class is referred to as derived classes. The existing class that we took information from is referred to as a base class. Now, sometimes it's referred to as a derived class, base class. Sometimes it's referred to as a child class, parent class. So the new class is referred to as a child. The old class is referred to as parent. So the derived classes inherit properties of the base class. You can have single inheritance, where basically you have a derived class come in from a single base class. You can do multiple inheritances, where you can have one class inherit from more than one parent class or base class. And you can do public inheritance, where basically all public members of the base class are inherited as public members of the derived class. Inheritance can be viewed as a tree-like hierarchy structure, because again, it's a parent-child type of a relationship. So if you can kind of imagine a family tree, if you will. So for example, the shape class, someone else, let's say, already wrote a class called shape with all of the functions and variables on there and already defined. And you realize that in your project you have to write up a circle class. Well, because a circle, or every circle, is a, so this is a is-a relationship, every circle is a shape, we can use inheritance in this case. So you can actually just go ahead and take that shape class that somebody else wrote, inherit from it for the circle class, and therefore now the circle class will have all of the shape classes, functions, and attributes as almost as if it's the circle classes, functions, and attributes. So it's kind of like you having all of your parents' genes and inheriting from them. So it's this hierarchy structure. Therefore, mostly in inheritance, the parent class is a more general class. You'll notice shape is a very general term. It can be any type of shape. And it's the child class that's more specific. So once again, the parent class is usually more general, and the child class is more specific. So this is the base class, and this is the derived class. So what does the syntax for a derived class look like? So let's say somebody else already wrote a class, whatever name it is. So here we're just placeholders base class name. And your class, you want to inherit from that class. Well, this is a general syntax. When you're writing your class, you would just write it as you would any class. Keyword class and the name of your class. Open brace, close brace at the end with a semicolon. And then your member list goes in between. Well, all you have to do is after you name your class, you just put a single colon. Please don't use double colons because that's kind of a typical mistake students make when they first learn inheritance. All you do is use single colon, and then you specify an accessor specifier information like public, private, or protected, and then you just use the name of the base class. Now, of course, the accessor specifier can be public, private, or protected. If your class inherits from the base class as public, everything that's under the public header for the base class will become the public functions for the derived class. If you inherit as protected, everything in the base class would be as if they were protected members of the derived class. If you inherit private, everything in the base class would be as if they were members of the derived class under the private header. So it really depends on how you want to inherit all of the members of the base class to your derived class. So it depends on that. But what we're going to really focus mostly on is a public inheritance, because that's the one that's the easiest. So all you do is publicly inherit from your base class, and therefore everything public under the base class will also become as if they were members of the derived class under the public header. So let's look at an example. So here we have a person class. So you'll notice here's the header file right here, header file. So you'll notice we have a class called person. It's a very simple class. By the way, this code is in doc sharing for you if you want to take a look at it. Very simple class. It only has one private member called string name. It has one constructor, a parameterized constructor, because the constructor actually takes in a variable. And we have a set name and a get name, so we just basically have an accessor and a mutator. So here are the definitions for the person class. The constructor just takes in a string and it sets it to the private member name. Get name returns name. Set name just allows us to take in a string and then set it to the private member variable name. So here we have an employee class. So like we said earlier, an employee is a person, right? So we have a is a relationship here. So we can definitely use inheritance. And then here is the syntax for that. So when you're creating your class called employee, all you do is you put a single colon, the accessor specifier, public, private, or protected. So we're going to say public. And then the name of the class that you're inheriting from. So we're inheriting from the person class. Now, of course, please make sure that you have the person.h file included in your employee.h, because that's the only way your employee file is going to know that there is a person class in the person.h file. Alright, so all employee is going to do now is just make additions. So employee automatically, by just doing this, has access to a function called setName and getName. So we don't even have to write a setName and getName function for the employee class. It has inherited those those functions from the person class. So the only thing employee then needs is, let's say we were trying to also get employee's age. So all we need to do is add that, because the person class, as you can see, does not have those attributes, does not have attributes for age. So yes, we inherited everything from person, but let's say for our project we need more, so that's where we start adding our own stuff. Okay, so we're reusing code from the person class, but we're also adding our own stuff here. So, alright, so we're declaring an age variable that's hold integers, and then basically all we have in the employee class is just, again, another constructor that's parameterized, takes in two values, takes in a string and an integer. We have a set age and a get age, which are basically our mutator accessors for the age variable. So here's how the CPP file for employee CPP would look like. Of course, we're going to include employee.age. Here's our parameterized constructor. Notice now there's a little bit difference in definition, right? String in name is not in the employee class. It's in the person class. It's in the person class that we get to set a person's name. So notice as soon as the parameterized constructor for employee takes in string in and of course int a, all it does is just sends in over to the person class's constructor. And the person class's constructor, which is right here, we'll go ahead and take that in and save it as name for this employee. The A, however, is part of the employee class, the integer, so that's going to be set to age right here in the parameterized constructor of the employee constructor. So you'll notice the syntax is, again, a single colon, the name of the class, and then the passed in value without the data type. So we have the data type here, we say string, but when we pass it in, we just pass in the variable. So in is the variable. All right, then we just kind of define our functions as we would. So set age, we set age to A, which is passed in. Get age returns age. So employee class is written out that way. So now we have an employee class that inherits from a person class. So how is this used in int main? Well, here's our main.cpp. So here all we have to do is include employee.age. We no longer have to include person.age because employee.age includes person, right? Therefore, we just need to include employee, and indirectly we have access to person class. So all I have to do in int main is just create my object of the employee class. So I have an object called 1 of the employee class. And notice, even though 1 is an object of the employee class, I'm able to call the function setName, which is, as you can see, is not in the employee class's list of functions. It's actually in the person class's list of functions right here, setName. So how am I able to call from an employee object, 1, setName? How was I able to do that? Because employee inherits from person, and when it inherits, everything under the public header of person is almost as if it's considered as it's in the public header of employee. So everything in the public header in the person class is considered at this point as if they are all functions under the public header of the employee class because of this inheritance. So the employee class now has access to all of its own functions and all of the functions that are in the person class through this inheritance. So by creating an employee object in int main, I'm able to access anything under here that I'm circling right now and anything under here. Okay, so all of these are accessible by an employee object because it's considered, all of this is considered as if it is an employee object member, okay, or employee class member, excuse me. So now using my employee object 1, I can set name for an employee, I can set the age for that employee, I can use the parameterized constructor here. I created another object of employee called 2 and invoke the parameterized constructor, so Sue is 54. And then I can just go ahead and just see out and call get name, get age, get name, get age for the 2 different objects. This would print out name is John, age is 34. And this will print out name is Sue, age is 54. And it will do that fine just by using objects of the employee class, because remember, because of the inheritance, everything in the person class is considered members of the employee class. Alright, so that is inheritance. Thank you.